Creating 2D lists. Let's talk 2D lists. Actually, let's talk 1D lists. What if I were to print the list 1, 2, 3? It should come as no surprise that it's, well, the list 1, 2, 3. Interestingly, Python can allow for other types of values to be in lists. This should not be a surprise. I can do 1.2, 2.7, and that works fine. I can also mix and match types, true, comma, hello. Still no surprise. So what would happen if I were to create a list, L equals 42, comma, hello. What's the length of L? Well, that would be 2. All right, so far so good. Now, I can put any kind of value inside a list, including another list. Now, if I print L, look what's going on. This is the first element of L. It used to be 42. Now it's this list. It's the first element in L. The second element in L is still that string hello. If I were to print the length of L, sure enough, it's only 2. If I were to print L of 0, there's that list, and L of 1, there's that string, which is to point out that L of 0 is just another value like any others. Now, if I were to make L of 1 equal to, say, 2, 4, 6, 8, 10, now if I were to print L, this looks suspiciously like a two-dimensional list. And I can access its values, say L of, this is row 0, and so L of row 0, column 3 would be 0, the 4, and L of row 1, column 2, let's say column 4, would be the 10, because this is row 1, this is column 0, 1, 2, 3, 4. So indeed, this acts very much like a two-dimensional list. As far as Python's concerned, it's not, though. It's really just a one-dimensional list because that's all Python has, but that list is composed of other lists. This is a difference that we're going to essentially ignore in this course. We're going to, for the most part, assume that when we say two-dimensional list, that the user or the programmer provides us with one that meets our spec, which is to say, it doesn't mix and match types. All the values in a quote-unquote 2D list are lists. And in fact, they're all the same length, so that what comes out is a rectangular 2D list. In 15.1.12, unless we state otherwise, which would be rare, you're allowed to outright assume this fact so that you get a normal 2D list that you can handle and not some weird Python amalgamation. All right, with that said, let's see how you can create 2D lists. First way is through static allocation, which we see right here, which is to say, you simply say, here are the values in my list. And we run it, sure enough, it works just fine. 2, 3, 4, 5, 6, 7. I often find it's better to format this a little differently, to do it as such. And in fact, it might even be nicer to add this closing bracket to be in the same line as that first closing bracket. Because when I see the list this way, this screams to me 2D list in a way that the original, which we had right here, does not. Python does not care if you put these spaces in, and the reason Python doesn't care is because when you're inside brackets or parentheses, you can add new lines at your pleasure. All right, so that's static allocation. What about dynamic or variable length allocation? That is, I have a list and I want it to be of size n in one dimension, or here in 2 dimensions, of a given number of rows and columns, and I want to create a list of that size, a 2D list of that size. One way to do it would be as follows. To use the times pattern that we've seen for a 1D list, and to create a list of those times the number of rows. This looks like it works. If we were to print this out, we will get a 2D list of 0, 0, 0, two columns of 0, 0 by 3 rows. Great. The problem is, let's see what happens when we set a of 0, 0. And we run this, and you see that here's our initial list. I only set this value, and yet, look what happened to a of 1, 0 and a of 2, 0. They also got set to 42 by this one line of code. And this is because multiplication of lists creates a so-called shallow copy. So that is, it creates aliases. So each row is an alias of the other rows, which is to say they share a reference to the exact same list. There's only one row, and when we modify that row here, we modify every row, which couldn't possibly be what we intended. So much so that I would think it would be better to not have multiplication work this way over lists. But this is how it works. In any case, because of that, we just can't do it this way. This is an endless sea of bugs waiting to happen. So a better way is to construct the list ourselves by appending each row. We'll start out with an empty list. For every row that you want, you go ahead and destructively modify our list and add a new row. This actually works. Let's watch. Haha, well, when we modify a of 0, 0, we get 42 there, but we did not get 42 here or here, which is proof positive that this worked. Wonderful. So this little construct you have to do over and over again, and it's a little nuanced because you sure don't want to do it this way. So the last thing is it's not 100% clear what's going on. For all these reasons, it's best to put it inside a helper function. And here you go. This is the helper function that does exactly this up here. It creates that new 2D list and returns it. Now you can just call make 2D list of rows and cols, and that works just fine. And this is how we recommend that you do it in general. Okay. Finally, you can actually use a list comprehension. List comprehensions will create non-aliases, but in fact new rows for each time. So this right here works as well. I actually prefer to put the make 2D list approach. One thing you could do if you wanted to would be to drop a list comprehension inside the make 2D list function. That might be the clearest and most modern Pythonic way of doing things. And that is how you create static and dynamically sized 2D lists.